Hello everyone, welcome to Audit Course Week 7 Part A. Today we are going to discuss the procedure for plotting the transfer characteristics for N-channel JFET. So before starting, let us understand what is JFET. So JFET stands for Junction Field Effect Transistor. Its symbol is like this. We have a gate terminal, drain terminal and source terminal. So this is the symbol for a N-channel JFET. Similarly, we can have a symbol for a P-channel JFET where the arrow to the gate terminal is outwards. Now, for a JFET, there are two important parameters. That is VP, that is the pinch off voltage, and IDSS, that is the drain to source saturation current. So for this circuit, we are considering the JFET parameters as VP is equal to -4 and IDSS is equal to 8 milliamperes. Okay, so we have two characteristics of JFET, that is transfer and output. In this session, we will be discussing only transfer characteristics. So for JFET transfer characteristics in common source configuration, we have to set up the circuit consisting of two voltage sources, naming as VGG and VDD, and the resistors will be RG and RD. And also we need to select the N-channel JFET from the component library. The name will be NJF. So just type NJF and you will get this N-channel JFET and place it onto your schematic. And also give the value of RG as 100 kilo ohm, value of RD as 1 kilo ohm. Now select the voltage sources from the library for VGG and VDD, and we need to right click on the VDD voltage source and enter its DC value as 15 volts. Similarly, you need to right click on the VGG source, but this time do not enter the DC value. Click on advance, none will be selected, and click on OK. This is done so that we can vary the value of VGG. Okay. Next, if we want to define our own JFET with NJF with own JFET NJF with IDSS and VP value, as we have told, IDSS and VP value is 8 milliamperes and -4 respectively. So if you want to define it, as given, that is 8 and -4, we need to do the following. So we need to right click on the NJF over here. So right click on the NJF and rename it as NJF1. Now from the rightmost corner of LT Spice, locate .op, click on it and select the Spice directive. And we need to type the following line. There is .model NJF1, which is the reserve word defined by the user, then followed by space NJF, which is the reserve word indicating that it's an N-channel JFET. Then in the bracket we need to add two parameters, that is VTO equal to -4 and beta equal to 0.5 e raised to -3. Now this 0.5 e raised to -3 means 0.5 into 10 raised to -3. So in Spice it is e raised to -3. So this statement will set IDSS equal to IDSS equal to 8 milliamperes and VP equal to -4. Now actually we want to enter VP and IDSS, but we cannot enter directly. So VP is written indirectly in the dot model as VTO and IDSS is written indirectly in dot model as beta. So beta will be equal to IDSS upon VP square. So if you substitute these values, the beta will be IDSS upon VP square. You will get it as 0.5 e raised to -3. And VP is entered as VTO equal to -4. So that's the way we indirectly enter the parameters IDSS and VP in the dot model statement. After you have written the dot model statement, click on OK. So dot model NJF1 NJF bracket VTO equal to -4 beta equal to 0.5 e raised to -3 will appear on the schematic. Or we can do is we can right click on the NJF transistor symbol, click on the new transistor and scroll down and select 2 and 5484 from the component selection and click on OK. So this is a practical N-channel JFET, but for today's lab, you need to do this generic definition for NGF1. So follow this method of NGF1 and give the user defined values of IDSS and VP values. Next, for the JFET transfer characteristics, we need to label the drain, gate, and source terminal of the N-channel JFET as capital D, capital G, and capital S. So to add a label, you need to right-click on the wire, and click on the label net, enter a label as example D, and click on OK. So once you do that, you need to, this labels will appear on the screen as capital G, capital D, and capital S. So again, I repeat, we need to right click on the wire, click on the label net, and add the label over here as capital G, capital D, and capital S. So after we have done that, once your circuit schematic is ready with all the dot model parameters and the labeling, go to simulate, click on run, and then click on then next select DC sweep. So there you need to enter the name of the first sweep, so enter it as VGG. Type of sweep will be linear, start value will be -4, stop value will be 0, and increment will be 0.1. Then you need to click on OK. So this step means that we are varying the value of VGG voltage source linearly from -4 to 0 volts in the step of 0.1. Then click on OK. This dot DC VGG -4 to 0.1 statement will appear on the schematic. Also at the same time, a new blank window with x-axis from -4 to 0 volts will appear. Okay. So now for plotting the transfer characteristics, that is plotting ID versus VGS. Actually, it's wrong over here. It should be ID versus VGS because we cannot plot IG characteristics in for a JFET because the current is almost 0. So please change it. This is ID versus VGS. So after the blank window appears with the x-axis going from -4 to 0 volts over here, from the step, after you click on OK, so click on OK, and this dot DC VGG -4 0.1 will appear. What you need to do is right click anywhere inside the blank window, waveform window, click on add trace, select ID of J1, and click on OK. So once you do that, you will observe a curve of ID versus VGG, which will look something like this. Okay, but we wish to plot ID versus VDS. Sorry, we need to plot ID versus VGS, not VDS. So there is a mistake over here. We need to plot ID versus VGS. Okay, so what we need to do is right click on the x-axis of the plot. So you will see that now the quantity to be plotted will be VGG. So you need to right click and change it to V of capital G. Okay, so and click on OK. So why we do that? Since the source terminal is grounded, my VGS will be VG minus VS will be equal to VG minus 0. Hence VGS will be equal to VG. So when we change it to V of capital G, that means we are plotting VGS only. So when you click on OK, the desired ID versus VGS plot will appear. So this is the ID versus VGS plot at a constant value of VDD equal to 10 volt. So it will be, the x-axis will be ranging from 0 to 4 volts, and the y-axis will be ranging from 0 to 8 milliamperes. Here if you see, notice carefully, at 8 milliamperes is nothing but your IDSS, and -4 is nothing but your VP values. And from this curve, you need to note down the different values of ID for different values of VGS. So these are the different values of VGS: 0 volt, -0.5 volts, up till -4 volts. So you note down the value of ID for these different values of VGS, and you will get this transfer characteristics, which will be in the second quadrant, wherein the ID values is positive and VGS value is negative. So that's how you plot the transfer characteristics of N-channel JFET. So I think that's it for this online session. We have described the procedure for plotting the transfer characteristics for N-channel JFET. So in the next lab, we will be plotting the output characteristics of N-channel JFET. So until then, have a good day and thank you.